Hello everyone. Today we're going to discuss how to separate the different components of a mixture. We have already learned what is a mixture and what are the different components. So how we are going to separate those components, that we are going to discuss in today's video. We are going to discuss the different methods or the techniques that are used for the separation of the components of a mixture. So in this video we are going to discuss some of those methods. So let us begin. Now most of the natural substances that we see around are not chemically pure. Yes, they are not pure substances. We have already discussed in the initial part of this chapter that what are pure substances. And not all the substances that we find in our surrounding is pure. So that means they are composed of different components, and we have to separate out those components. Clear? Now there are different methods through which we can separate the different components of those mixtures. Now in order to separate the components of a mixture, there might be a single method or there might be a combination of methods. It will depend upon what type of mixture it is or how many components are present in that mixture. Depending upon that, which method to be used and how we can separate out those components using that method. Now selection method will depend upon the nature of the components present in the mixture. As I said just now, that which method will be used, it will depend upon the components present in that mixture. Now heterogeneous mixtures can be easily separated by some physical methods like handpicking, sieving, filtration, etc. that we use in our day-to-day life. But are only these methods enough for us? No. There are some other mixtures which cannot be separated out through these physical methods. We need some other methods or techniques to separate out their constituent particles. So sometimes we need some special techniques for the separation of the components of a mixture. For example, separation of colored components, that is dye from ink. If you have to separate out the dye from the ink, we cannot use this method of hand picking, sieving, filtration. This won't work. So we need there some special techniques for the separation of those mixtures. So now we are going to discuss one by one the different methods or the techniques through which we can separate out the components of a mixture. So the first one is evaporation. Now evaporation we have already discussed in the chapter 1, that what is evaporation. Still let us recapitulate what is evaporation and how this evaporation can help us in the separation process. So the process of conversion of a substance from a liquid state to a gaseous state is called evaporation, and the substance which gets evaporated is said to be volatile. Now this is well known to us. Now the method of evaporation that we use is generally used to separate a volatile substance and a non-volatile substance. Or we can say it is used to separate out the volatile component, that is the solvent, and the non-volatile component, that is the solute of a mixture. We know that there are mainly two components in a mixture, that is the solute and the solvent. And to separate them out, if one of the component is volatile and the other one is non-volatile, then we can use this method of evaporation. This is very much useful in that case. Now what happens actually in evaporation is that on heating the mixture, the volatile component will evaporate, leaving behind the non-volatile component. Say for example, the common salt that we eat, how it is made or how it is prepared from the seawater. What actually is done is that the seawater is evaporated by the help of the heat of the sun. And when this sea water, it evaporates, leaving behind the common salt as the residue. So after evaporation process takes place, whatever is left behind, the water will evaporate. So something will be left behind, and that something is nothing but it is the common salt. Clear? So by evaporation process, we can get the common salt. Now there is an activity given in your textbook, that is 2.4, how to separate out dye from ink. Now we know that ink is nothing but it is a color, and dye means color. So how to separate out that color from that ink? That color is actually mixed with a solvent, and then only this ink is formed. So let us now see how this dye is separated from that ink. So this is the setup for the experiment. Now as you can see, these are the things given, like the watch glass, the ink, the beaker, the water, the Bunsen burner, the tripod stand. All these things are given. So what to do is that we need to first fill half a beaker with water. Half a beaker we will fill with water, as you can see in the figure, and then we'll put a watch glass on the mouth of the beaker. So as you can see, a watch glass is been put on the mouth of the beaker. Means the beaker is covered with the watch glass. Then we put a few drops of ink on the watch glass. We'll put a few drops. Now what we need to do, we need to turn on the Bunsen burner. The burner you can see at the bottom. Then we will start heating the beaker. Now as the beaker gets heated up, the water will evaporate. Means it will produce some steam or water vapor, which we say. And this water vapor will again heat up the watch glass. And as a result, the ink that is present on the watch glass will also start evaporating. Now we have to continue this evaporation until and unless the ink gets reduced to the dye. That means the ink is what? It is a liquid. It will evaporate, and you will see that slowly and gradually the amount of the ink will reduce, and it will reach at some point where no more evaporation process is taking place. So then you can see that there will be a residue left behind on the watch glass, and that residue is nothing but that is the dye from the ink. Then we can turn off the Bunsen burner, and then we can take out the watch glass from the mouth of the beaker, and we can separate out the dye that we have obtained as the residue of this experiment. So what we observe is that through the process of evaporation, we can separate out the dye from the ink. Is it clear? Now, how did this happen? This happened because the dye was non-volatile in nature, whereas the solvent that was mixed with the dye to form the ink was volatile. Its boiling point was less than that of the dye. As a result, it got evaporated, leaving behind the non-volatile component, that is the dye. Is it clear? Now moving on to our next topic, that is called centrifugation. Now this method already was mentioned in the colloidal solution, that colloidal solutions can be separated through this process of centrifugation. So let us see now what is actually centrifugation. Now sometimes what happens is that the solid particles in a liquid are very small. Hence the solute that is dissolved in the solvent is very small in size. It is so small that it can easily pass through a filter paper. So that means we cannot separate out the particles through filtration method. For example, the colloids, as I said, they are such kind of heterogeneous mixtures which cannot be separated out through filtration process. They are not like any other heterogeneous mixture like sand and water. They can be separated through filter paper, but we cannot separate out milk through filter paper, isn't it? So what to do then? There is some method, obviously. So such mixtures can be separated out through this process of centrifugation. Now what actually is centrifugation? Let us see. When two components having difference in densities, then we can separate out through this method of centrifugation. So if there are two components, the two components are nothing but the solute and the solvent. If there is a difference in their densities, density of the solvent and the density of the solute, then we can separate out through this method of centrifugation. Now this method is based on the principle that the denser the particles are, they are forced to settle down at the bottom, and the lighter particles stay on top, means they are floating on top when they are spun rapidly, means there is a spinning process. There is something called the centrifugal force being applied. So when we apply the centrifugal force, there is a spinning process. When you spin it very rapidly, then what happens? The denser particles that settle down at the bottom and the lighter particles that come up at the top of the mixture. Now a device that is used to separate out the liquid from the solid by spinning is called a centrifuge. So this spinning process, which spins very rapidly. So in this spinning process, that device which helps to carry out this spinning process to separate out the solvent and the solute part, that machine is called a centrifuge. Now centrifugal machines are commonly used for this method. They are also called centrifugal machines. Now the machines can be rotated either by hand, that is manually, or electrically. Yes. Now the centrifugal machines have this provision that they can either be run by our hand manually, we can rotate it with our hand, or it can be done electrically. Nowadays modern methods use electrical methods, but initially people used to do it with their hand manually. Now let us see how they do it. So this, now I guess all of you have seen this process being carried out traditionally in India in the villages. Now what is this method? This is nothing but they are trying to separate out the cream from the milk. Now this is a manual centrifuge machine, you can say. We will not consider it as a machine, you can consider it as a tool, but as you can see here, the woman is rotating that cylindrical stick like thing in that pot, and she is rotating it. Although it is not spun at a very rapid speed, but still she is, with the help of the thread, she is rotating it. As a result, there is a centrifugal force being created, and it is acting just like a centrifuge or a centrifugal machine. And in this way, if she carries on, then she can separate out the cream from the milk. Later on, since this is a handmade tool, later on there was some modification that was carried out in the machine, and this has been invented. This is a centrifugal machine, although here, as you can see, there is a handle being given here, just like the handle of a, or you can say the pedal of a cycle. We can rotate it with our hands. As you can see, the milk is on the right hand side of the figure. You can see the milk has been poured, and there are two buckets. One side the skim milk is coming out, and other side the cream is coming out. Yes, what actually happens in centrifugal machine is that when we pour that milk and we rotate it very rapidly, we rotate it continuously, then what happens, after some time you will see that some white substance comes afloat, means they are floating on the milk. That is nothing but that is the cream. So we can easily separate out with our hand or through the machine itself, and that part is called the cream. And whatever is left behind is the skimmed milk, means the milk without that fat or the cream. Now nowadays we have seen in the market, in the Tetra Paks, in Tetra Paks you have seen it is written toned milk. So that toned milk doesn't have that cream in it. but actually the milk should have that cream, otherwise milk is nothing, it is like normal drink. So when you separate out that cream, then that kind of milk is called toned milk or skimmed milk. Clear? So this is possible with the help of this centrifugation process. So as we know, milk is a colloid, so we have separated out the solvent and the solute part. The solute part here is the cream and the solvent part here is the skimmed milk. Clear? Now moving on to the next method. Now what are the applications of centrifugation? Before going to the next method, let us see what are the applications of centrifugation, where this centrifugation process is used. Now centrifugation technique is used in, number 1, in diagnostic laboratories for blood and urine tests. Yes, all of you may have seen the laboratories where these tests are being done, such as blood test, urine test, again different kinds of tests. So especially for this blood test and urine test, if we need to separate out the components of the blood or the components of the urine, then the centrifugation process is applied. There is a machine, as you can see in the figure, where the samples of blood and urine are put and then they are spun very rapidly with the help of the machine, and it easily separates out the different components of blood and urine. Here, next, they are used in dairies and home to separate butter from cream. They are used in dairy farms or even in homes also we can use it. So for example, this machine, which already I have shown in the previous slide. So we can separate out cream from the milk, and again from the cream, if we spun the cream rapidly, we can get butter from it. So you can relate the process now. First of all, we get cream from the milk, then we get butter from the cream. Clear? So butter is the final out product. Furthermore, we cannot go. Next, it is used in washing machines. Now you are quite familiar with this, how washing machines work. They have to squeeze out the water from the wet clothes. As you can see here, I put some clothes in the washing machine and it is spinning very rapidly. Now this process is nothing but it is a centrifugal motion or centrifugal force being applied. So it is rotating very rapidly, and as a result the dirt and the water is squeezed out from the clothes. So you are quite familiar with this washing machine, how it works and how it spins rapidly. Clear? Now let us move on to the next method, that is separation by using a separating funnel. Now how can we separate two liquids? If we are given two liquids, then how can we separate them using this separating funnel? Let us discuss. Now this method is used to separate a mixture of two immiscible liquids. Now what is immiscible? Immiscible means they are not mixed. Even if we try to mix it, they will not get mixed. After some time, they will separate out. We can easily distinguish the two liquids. They don't get mixed with each other. So that is the meaning of immiscible. Now this method is based upon the principle that immiscible liquids separate out in layers depending upon their densities. Yes, as I said, immiscible liquids that don't mix with each other, so eventually they will separate out. We can easily distinguish the two liquids. There will be a layer of separation among them. Now as you can see in the figure, this is a separating funnel. So we are here separating out what is called the kerosene oil and water. We know that oil and water, that doesn't mix. So oil and water are two immiscible liquids. So what we have done here is that we have put some amount of kerosene oil and water, and we are trying, then we will shake that separating funnel. As a result, what will happen is that for some time it will look like it has been mixed, but as we know, they are immiscible liquids. So after some time, if we keep it undisturbed, then we can easily see the separation that has occurred between kerosene oil and water. There will be a fine layer of separation between kerosene oil and water. Then what to do is that we have to open this stopcock. So this stopcock, if we open it slowly, not in a very rapid way, slowly, if we open the stopcock, then we can easily separate out the water. The water will be at the bottom and the kerosene oil will be at the top. Clear? Since kerosene oil is much denser than water. Since water is denser than kerosene oil. So that's why water is at the bottom and kerosene oil is at the top. So what will happen is that we can slowly open the stopcock and let the water pour out from the separating funnel. So in this way we can separate out the water and the kerosene oil. Whatever will be left in the in the separating funnel, that will be nothing but the kerosene oil. So in this way we can separate out kerosene oil and water. Clear? Now let us see some of the applications of this method. So where this method is used? For the separation of a mixture of oil and water? Yes. Any kind of oil, not only this kerosene oil, any kind of oil. We know that oil and water doesn't mix. So we can use this separating funnel for separating out that water and the oil. Clear? Then in the extraction of iron from its ore, the lighter slag is removed from the molten iron ore. When the iron is extracted, the ore is what is done to the ore? It is being heated up. Now while heating it up, the iron ore, as we know, iron ore is mixed up with a lot of impurities. So these impurities, they float on the molten iron. When the iron turns into liquid state, that is in the molten state, then these impurities are lighter than that iron. As a result, it will float on the top of that iron, molten iron, and then we can easily remove that slag, that impurity from the top with the help of this separating funnel method. Although there the funnel is not that small, it is quite bigger, but this same technique or this same method is being used for separating out the impurities that is present in the iron ore. Clear? So I hope you all have understood today's class. In the next video, we will discuss furthermore with some other techniques that have been used for the separation of the different components of the mixture. So that's it then for today. Thank you and have a nice day.